Hi everyone, welcome to the Mathemagic channel. Today we cover some harder question in the Pythagorean Theorem series. Make sure you do parts 1 and 2 first before you attempt these questions. These ones are a little bit more challenging. Let's jump in right now. Let's go. So a few pointers before you get started. The first thing is to try and understand that in order to do these questions, you're going to have to be a little bit organized. And so for you to do this properly, I would suggest that you mark down everything that you know. So if you know some of the measurements, mark them down on the actual question. Also stay organized. And if a question is asking you to solve like X, Y, Z, perhaps you should do X first and then the Y and then the Z, not the Z first, because that's probably the last part of the question that you need to solve. So stay organized, mark everything down that you know, and also use clear labels so that if you're calculating a new length, you explain to your examiner that you're explaining that you're trying to find this length, and you say, I'm going to call it B, or I'm going to call it C, or whatever you want to call it. So labeling is very important as well in order to get really good marks in mathematics, and also for you to be able to backtrack through your work so that you know where you might have made a mistake. So with that in mind, let's jump to these 6 questions. And so I would suggest you pause the video here and you try these questions. You can also pause the video at the beginning of each question and you'll find the chapters in the description. So whatever you prefer doing is fine. Go ahead, try these, and then we do the solutions together. Good luck. For your first question, assuming you've managed to try at least and do your best, you realize that you have an X and a Y. Again, we need to do the X first and then the Y. So perhaps we start with the X in the first triangle, which is like a 1, 2X triangle. And it's a 2-part question, so that's what's really important here. First we find X, then Y. Let's find X. We start with the hypotenuse squared equal. X is the hypotenuse, so we'll say X squared equal 1 squared plus 2 squared. And 1 squared is 1, 2 squared is 4, so this is going to be 1 plus 4, which is 5. So X squared is equal to 5, and we need to square root now. So we can say that X is equal to the square root of 5. And we can mark that down on our graph here. So this is in our first triangle. And now we can look at finding the second length, which is Y. And in the second triangle, Y is the hypotenuse. So in the root 5, 1, Y triangle, we can say Y squared equals. And then we're going to get root 5 squared, which is nice because the root 5 and the 5 and the squared cancel out. So this is going to give us 5 plus 1 squared, which is 1. So 5 plus 1 is 6. And Y squared equals 6 means we should end up with Y equals the square root of 6. And you can mark that down here, root of 6, and you're done with this question. If you've managed to do this, well done. That's your warm-up question. Very good. In question B, we have a trapezium shape, and we notice that there's some markings. So that indicates that the 5 is equal to the 5 on the side. So most likely, because this is a 5 and this is a 5 and you have a right angle, we're looking at a square shape. We need to find X, then we need to find Y, similar to the last question. But I would encourage you first to mark down all the 5s that you know, so that one of them is involved in the triangle on the right hand side, and one of them is involved in the base of your trapezium. So there's a 5. And if you know the base length is 8, then probably the X value is going to be related to that. So we can find X quite easily here. We can say that 5 plus 3 is equal to 8, or X is equal to 8 minus 5. And that will give you X equal 3. So we don't even need to use Pythagoras Theorem for that. We're quite grateful to do that. And then here to find Y, well, we have a right angle triangle. Y is the hypotenuse, so we can start with Y squared equal. So let's do that. Y squared is 5 squared plus 3 squared. 5 squared is 25. 3 squared is 9. 25 plus 9, that's going to be 34. So Y squared is 34. And to finish this question, we should say Y is the square root of 34. So square root of 34 is going to be good here, and we're happy to have that as our answer. Okay, very good. That's the first 2 questions done. Awesome. Let's move on to the third one. In this question, we have a right angle triangle with an X value to find and then the Y value. So it seems like a 2-part question again, where first we find X, then we find Y. So let's go ahead and do that. So X squared is going to be equal to 6 squared plus 8 squared. 6 times 6 is 36. 8 times 8 is 64. So we get 36 and 64, which is 100. And so if we do the square root of 100, we'll find 10, which is nice. So we can mark down 10 here. So that's the length. And if we look at the second triangle, we'll get Y squared is equal to 10 squared plus 2 squared, so we can go ahead and do that. Y squared equal 10 squared plus 2 squared. 100 plus 4, which is nice, it's 104. And we can square root 104, so we can say the square roots of 104. However, we notice that 104 has a perfect square. It is 4 times 26. So if you break 104 down into 4 times 26, you notice that 4 is a perfect square. And the rule is that perfect squares can leave the square root. So the most simplified version you might find in your book here is actually 2 root 26, because the square root of 4 will become a 2. And so 2 root 26 is good here. And so we can say that y is 2 root 26. Of course, you could write a decimal value. In these questions, we're focusing on finding the exact values. You could always use a calculator. That would be fine. Okay, in question 4 here, we have a trapezium again. I would encourage you to write the lengths that you know. We should probably not assume that y is 9, although it looks that way. We'll just write that y is y, okay? Don't make assumptions in mathematics. It's very tricky. Sometimes you could make an assumption. You think, oh, it looks like a square. Nobody told you it was a square. All you know is that the 9 at the top is the same as the 9 at the bottom. But you don't know that the side lengths are 9. And by the way, y is the last thing you should find here. So probably be a little bit careful. It might be close to 9, but might not be exactly 9. However, we could probably find x here. So we have 15 minus 9, similar to one of the previous questions, which is going to give us x equals 6. And once we have the 6, then we should write it down. Stay organized so you don't forget what you did. And now we can find the y value. So looking at the triangle on the left here, we see that the hypotenuse is not y. So it's very important to start with 7 squared equal so you not make a mistake here. So you can say 7 squared equals 6 squared plus y squared, remembering to start with the hypotenuse. Don't say y squared equal, because then you're going to make a mistake. So 7 squared equal y squared plus 6 squared. We can figure those out. 49 is y squared plus 36. Following the rules of mathematics, the 36 moves to the left. Plus becomes minus. 49 minus 36 is equal to y squared. So far, so good. That's going to give us 13. So 13 is y squared. And then we need our final step here, which is the square root. So very important to square root 13 and put that in place of y. So y has the value square root 13. Square root of 9 is 3. Square root 16 is 4. So it's a number between 3 and 4. Again, you can use your calculator to find the exact value. But root 13 actually, this is the exact value. You can use your calculator to find an approximation. This value is better. Okay, let's move on to question E. Well done, everybody. Question E looks like the Pythagorean snail here. Okay, so let's mark down everything that we know. We have like some side lengths which are marked equally. So these are all 1s. And so if these are all 1s, you could probably well, you're going to have to find x, then y, then z, but you could probably mark them down first. So 1 here, and a 1 here. Okay, so now we're ready to go. So we could find x, then we find y, then we find z. Okay, so to find x, we're going to have to do x squared equal, the hypotenuse is x, so in the left-hand side triangle, x squared equals 1 squared plus 1 squared. 1 squared is 1, so that's 1 plus 1, which is 2, and then we square root it, so x is going to be equal to the square root of 2. Okay, that's good. Okay, so we found x equal root 2. We're pretty happy, and we can mark that down on our graph. And now we have a new triangle with the root 2, the 1, and the y, so we can find the y value. Y will be the hypotenuse, so you could say y squared equal 1 squared plus the root 2 squared. That's 1 plus 2. 1 plus 2 is 3. So then y is equal to the square root of 3. And we can mark that down. Good. And now for our last triangle, we'll have z, and again z is, so you see a pattern here, is that each time we have a new hypotenuse, 1 squared plus root 3 squared, and we seem to be increasing by 1 every time. Like we have root 2, root 3, probably this is going to be root 4. So z squared is equal to 4, 3 plus 1, and z is the square root of 4. Incidentally, the square root of 4 is 2, so you could say z is equal to 2, that's fine. However, just for the sake of the actual snail, you could say that z is the square root of 4, but if this was an answer in a test, of course you should write that z is equal to 2. So this brings about a nice little interlude here, that this is actually the Pythagorean snail. And so the Pythagorean snail, which is also named the wheel of Theodorus, starts like this. It's got like a root 1 and a 1, a root 2 and a 1, a root 3 and a 1, and it's one of those sacred geometry type shapes. So as you can see, it goes all the way through to root 17 here, but it's an absolutely beautiful shape, and it does follow some pretty interesting rules. There's some versions of it that you might find on the internet which you might be interested in seeing. Some people have colored it in. It's a good practice question to do for yourself as well. And yeah, some beautiful staircases and things like that. Anyway, that's not part of this video because we're doing the 6 questions that we're doing, but just for you to realize that, you know, mathematics is found in art as well, and this is an example of that. On to our last question for today, which is question F here. And for question F, we seem to have, it looks at first like this is a square because we have 4 lengths which are equal, 10, and then there's 4 tens here, then there's a 7 in the middle. There's something a little bit strange about this. If this was a square, then the outside angles would be right angled, but nothing here says that the outside angles are right angled. And if it was a square, then you would just have 14 across, and that would be the end of the question, and you wouldn't need to use the theorem. So don't assume that it's a square. It's not. It's a rhombus. Otherwise, it would just be, you know, all lengths equal, and it's not like that. So let's first mark down what we know. So we know that this is a 10. So probably we need to use a label for the thing that we don't know. Now you could mark it as a half of x. That's totally fine, but it's a little bit complicated for calculations. So let's just mark something different, like a. You're allowed to do that. You're allowed to take control of the question and say, I'm letting a be this distance here, which is the half distance from the center to the outside, and knowing that x is equal to 2a. So once we finish the question, we can always revert to x is equal to 2a. Again, using half x will be totally fine, but this is just to make the question easy. So finding a, well, we use Pythagoras Theorem, starting with 10 squared equal. So 10 squared is equal to 7 squared plus a squared. This leads to 100 equal 49, so 7 times 7 plus a squared. The 49 moves to the other side, so plus 49 becomes minus 49, so 100 minus 49, which is equal to a squared. 100 minus 49 is 51, so we can say 51 is equal to a squared. And then we need to use the square root of 51, so the square root of 51 is equal to a, and we can mark that down. However, we're looking for x here, so we probably need to multiply that by 2 first, and 2 times the square root of 51 is 2 root 51, and that's totally fine. And the little triangular 3-dot thing that I marked down for you is therefore. So we can say that therefore, so if a is the square root of 51, therefore x is 2 times the square root of 51, which you can find on a calculator. 7 squared would be 49, so a number just above 49, so is 51, so probably just above 7 times 2, just above 14. So a is just a bit bigger than 7. So it's 7 and then 7 point something. So a is not quite the same as 7 here. So it was good that we didn't make the assumption that it was 7, because it was not. So well done for doing this question. If you got 2 root 51, that's absolutely amazing. Good job. You can mark that down. Thanks for doing these questions today. Like, subscribe, follow us, and see us in part 4 for some more Mathemagic. See you next time.